So good morning and welcome to today's Cundinger Presents featuring the Parker Filtration Group. We're going to be talking about maintaining healthy hydraulic systems today. Phil, you can go to the next slide. So I'm your host, Joe Alberts. I'm an account manager with Cundinger. And then in a few moments, we'll be joined by Phil Holt. He's our hydraulic filtration territory manager with Parker Hannifin. Just a couple things of note today. All participants have been placed on mute. If you have any questions at any time during the presentation, please use the chat feature in the application control panel. We'll monitor this, and if we see any questions pop up, we'll answer them as they come along, or we'll have a little bit of time at the end as well to answer those questions. After today's presentation, if you have further questions or want to discuss other Parker filtration products, please reach out to your Cundinger contact or email our general inbox at sales@cundinger.com. You can also call us at 1-800-242-4811 and we'll get you to the appropriate person to help you. In the application control panel, I've also placed some links to some valuable resources. These are links to PDF files and a website for the Parker hydraulic, healthy hydraulic fluid type document and the filtration group's website. So you can go there and link up to those and download that PDF if you'd like. And then also today's session is being recorded and will be available on Cundinger Inc.'s YouTube channel for future review or to share with your colleagues. So just search for Cundinger Inc. on YouTube to find that channel and access this along with other previous Cundinger Presents sessions we did. So now let's welcome Phil Holt from Parker Filtration to walk us through maintaining healthy hydraulic systems. Phil, take it away.
Awesome. Thank you, Joe. And thank you everyone for taking the time to attend this webinar today with Cundinger Presents. I'm going to be going over healthy hydraulic systems with you. As Joe mentioned, I am the territory manager for the hydraulic filtration group here with Parker. Joined Parker back in 2019 and had previous experience before that with Donaldson Company. My background is actually in aerospace engineering, where I graduated from Purdue University, and I'm now located in the greater Minneapolis region. If you have any questions, feel free to reach out to Joe with questions for your systems, or also my contact information is listed right there, my email, as well as my direct line to my cell phone. So just for a background in Parker as a whole, I kind of want to go over what Parker as a company is. We have our 6 main technology groups that we are centered under, and with my group being underneath the third tile there, the filtration group. Parker as a whole serves over 104 different countries with over 100 different divisions, 13,000 distribution locations, with Cundinger being one of them. Over 57,000 employees are employed by Parker Hannifin. We have over 293 now manufacturing locations spread across the world. So within the overarching bubble of Parker, the filtration group purpose is to protect and to purify our customers' toughest applications with diverse solutions. So to protect, our filtration technologies ensure the efficiency, health, and safety of your equipment, all while extending its life cycle. And as what we'll talk about today with hydraulic filtration is really about extending that life cycle inside of your products and preventing premature failures of your systems and reducing your overall cost of ownership of your system, as well as increasing the reliability of your system as a whole. So the filtration group has 64 global manufacturing facilities. We ship products 24 hours a day, and we have 38 different technology and R&D centers. One of those is our Parker Filtration Media Research Lab, which I can talk a little bit more about later if people are interested, but it's a very cool facility located over in Ohio, and that's where we can develop new groundbreaking technology medias to help improve our filtration technology. And as I mentioned, we have over 3,000 different distributors that we work with Cundinger being one of them. Some of the brands that fall underneath the Parker Filtration Group that you might have heard of include AirGuard on the HVAC side, Baldwin Filters for on-engine oil and fuel, Clark Filter, you might have heard Pico Facet, formerly Pico Facet, Raycor Filters, as well as Smog Hog, Dust Hog, Dominant Hunter, a few other brands on there you might have heard before. The engine mobile hydraulic and fuel filtration, also known as EMHFF inside Parker, shortened to HFF or H&L, hydraulic and lube or hydraulic fuel filtration, is located out of Metamora, Ohio. You can see a picture right there, surrounded by the cornfield that we are there, or soybeans, depending on what the farmers decide to plant that year. But all of our filters are shipped out of this location here in Ohio. We do most of our assembly as well as integration there, and then we ship most of our products from that location as well. We do also have locations in Lancaster, Pennsylvania, and Saltillo, Mexico, but those primarily serve our rail markets and are not what you'd be using in your facilities on a day-to-day basis. The way that our filtration territory managers are broken out is into different geographic territories. As you can see here, my territory covers Minnesota all the way down to Kansas and Missouri, including the UP of Michigan, so very close to Cunninger's backyard here in Wisconsin. So I'm just a quick drive away, located in Minnesota here. So with that, we're going to dive into the hydraulic and lubrication basics. And really what we're going to talk about today is there's three main types of contaminants that you can have inside of a hydraulic fluid. The first one being particulate, with the two differentiations there being chips, which are larger than 5 nanometers, and silt, which is smaller than 5, down to 0 nanometers. Next, we have our water, both free water and dissolved water, and then finally air. So particulate contamination is broken into two different categories, as I've talked about. First being silt, which is particles less than 5 nanometers in size, and these lead to system component failure over time. So think of very fine grit and grime that's inside your hydraulic fluid that over time degrades your system and then leads to leaks and failures in that way. The next thing that we have is chips, which are particles greater than 5 nanometers in size, and these can lead to immediate catastrophic damage to a system, whether it be a servo valve, a hydraulic piston, you name it. But with those larger particulates in there, they can really wreak havoc on a very quick timeline, excuse me. So the big thing that a lot of people think about when they are talking about their system is they're like, oh, well, once I put my fluid into my system, it's going to stay clean because the system is sealed. And that is an incorrect thought there. The typical ingress rate for particulate greater than 10 microns, for particulate is really dependent on your application. So we have mobile equipment, manufacturing plants, and assembly facilities. So basically, the dirtier that your facility is in, the dirtier the environment your facility is in, the more particulate you will be ingressing into your system. And if you look at this, you have 10 to the 8th to 10 to the 10th particles per minute while your system is running, ingressing into your system. So your oil can get really, really dirty very quickly while in a mobile equipment setting. The same goes for manufacturing plants and assembly facilities, but those are cleaner environments, so we do see less ingress, but there's still a large amount of ingress into the system. And we're talking on a per minute basis here while the system is running, not over a day or a year. This is every single minute that your system is running. So new fluid contamination is one thing that we like to talk about. Is a lot of people think that when you buy new hydraulic fluid, it's clean. And in reality, the fluid itself is not clean straight out of the drum that you're moving it from into your system. Typical new hydraulic fluid is not clean enough to be used in the system, and what we recommend to do there is actually polish or pre-filter the fluid while you're transferring it, and I'll talk about some options that we have for that later. The larger the volume being delivered means more contaminants in it. As you can expect, there's more volume equals more fluid. And then basically the best way to deal with this is you want to filter your initial fluid that you're using from your bulk drums into your system, and that will help you create a clean startup of the system when you initially add that fluid. So the results from particulate contamination inside of a system can be the increase in component replacement costs, the increase of your overall maintenance costs due to downtime and having to have more resources dedicated to fixing whatever happens to be broken on your system, loss of production, as I mentioned right there with your downtime, and then frequent fluid replacement, and with that also being the costly fluid disposal. A lot of people don't realize, but it can actually be more expensive to dispose of your fouled up hydraulic fluid than it is to actually buy new fluid. So the fluid replacement costs and disposal costs can actually be much higher than just the cost of buying new hydraulic fluid, and I'm sure a lot of you are familiar with that as well. So particulate contamination warning signals for in your system, you can have valve spool centering, leakage, chattering, you have pump failures, loss of flow, frequent replacement of pumps, cylinder leakage and scoring, and increased servohysteresis. And if you look on this slide right here, you can actually see where in these systems there's been dirt, silt, chips all in the systems, and what has resulted is scoring of the inside of that cylinder there. And as a result, it has the fluids leak by, and you start losing production, you start losing efficiency, and ultimately lead to the failure of your system. So we have some pretty simple steps that we can take to prevent particulate ingress into your system, as well as do some detection. And the first thing that a lot of people think is pretty simple, or a pretty simple concept, but a lot of people overlook, is utilizing air breathers on your reservoirs. I can't tell you how many times I've walked into an application, there's just a reservoir that has a cap just hanging off the side of it, open to the air, and that just allows particulate and dirt to get straight into your reservoir where your fluid is supposed to be clean, just because someone hasn't put a cap or a breather system on there. A nice step to do is to flush the system before the initial startup. So make sure that you flush and put clean system fluid into it before you fire it up for the first time. Specifying rod wipers on your cylinders, replace worn actuator seals, cap off hoses and manifolds, as I mentioned before. And then a big step is to pre-filter your new fluid, just to make sure that the stuff that you're putting into your system is not just introducing new dirt. We sometimes joke about the fact that when you go buy new hydraulic fluid, you're just buying new dirt for yourself. And then really utilize testing tools to determine the accurate fluid cleanliness levels that you're actually seeing inside your system. We have a variety of products through Parker that can allow you to actually analyze your fluid, see how clean it actually is in your application, and then figure out what we need to do to make the fluids to the cleanliness level that you're looking for. So after we moved on from particulate, we have to talk about water contamination. Basically, there's two different types of water that we can have in our system. One is dissolved water, which is below the saturation point of oil, and so you will not see this inside of the oil. It is basically the amount of oil the water will dissolve, kind of like if you're thinking about dissolving sugar into water or salts into water. Same idea for water into the oil. The other type of water that we have is the free water, which is above the saturation point, and that will either separate into a layer on your oil, or it can be emulsified, as we see here on the right with that murkiness to the oil. That's actually a bunch of little water particulates that are trapped in between other oil particulates, and as a result, it makes that milkiness to the oil. Typical saturation points we have for hydraulic fluid is about 300 parts per million, or 0.03% of the oil. And then if we go all the way down to transformer fluid, that's where we really have to be careful. It's 50 parts per million is when you are going to hit your saturation point, and then anything above that will just be free water on the system. Lubrication oil is slightly more forgiving at 400 parts per million than the 300 in hydraulic fluid. The big thing that we run into with moisture in oil is it really can affect bearing life. And so a lot of the applications will have where there's going to be some sort of lube oil that is being used to lubricate a bearing, and we want to make sure that the water in oil is very, very minimal to extend the life of that bearing. So if you see here at basically 0.01, so 100 parts per million, you have 100% bearing life. And the thing is, you realize here, if you go even to just a 0.02, excuse me, which is 200 parts per million, just doubling, you decrease your bearing life by half in general. So realistically here, if we have the ability to decrease that water content in your oil even more from that 100 parts per million, we can increase your bearing life and allow you to run your system for longer without having to replace expensive components inside of it. So with water, there's very similar methods we can use to prevent it from getting into your system. First is to use a desiccant air breather. So As we mentioned, breathers for keeping particulate out, Parker also has a full line of desiccant air breathers, which have like a silica gel or a silica desiccant in it, which absorbs water out of the air before it enters into your system, and that will keep the water out of your oil on the reservoir side. Next is to flush the system again before you start it up with clean fluid, as we mentioned before. Once again, specify broad wipers and replace worn seals and actuators. And once again, cap off hoses, manifolds during handling and maintenance. So realistically, it's just trying to minimize the number of points of ingress that you're going to have foreign contaminant come in for both water as well as for particulates. So air contamination, I'm sure a lot of you have seen air inside your hydraulic fluid or inside hydraulic fluid at some point during your time. But free air is pockets of air trapped inside of a system. Dissolved air is just like water. You can actually have air dissolved into the hydraulic fluid itself. Entrained air, small air bubbles dispersed inside the fluid. So basically it'd be spread out. And then finally you have foam, which is large air bubbles on the surface. I'm sure a lot of you have seen that before in a poorly designed hydraulic reservoir. So air contamination sources can be system leaks, pump aeration, and reservoir fluid turbulence. I'd say probably the largest introduction of air into systems that we see is from the reservoir fluid turbulence. So basically, if you are putting your fluid back into your reservoir in a hasty, non-laminar manner, you can add foam, or it can be foaming, which will then entrain air into the system, which can be a major headache to deal with, as we can see here on that right picture. So air contamination results is we can have the loss of transmitted power because there's air inside the system. And the entire principle behind hydraulic systems is that fluid is non-compressible for our intents and purposes. And when you have air in there, air is compressible. So you can actually lose that transmitted power. You'll reduce your pump output. You can have pump cavitation, loss of lubrication. You can increase your operating temperatures. And as a result, you have your reservoir foaming. And there can actually be chemical reactions within inside your fluid as well. And the crazy thing about cavitation is people don't really realize the power that these small air bubbles can have when the actual bubble collapses. Because what happens is the initial bubble is a nice circle form, as we can see here on the top left picture. And the bubble begins collapsing, and it kind of creates a dent in, which then forms a liquid jet due to the pressure differentials in there. It can actually, and then when it explodes, it creates that liquid jet, which then can impact onto the metal surfaces, and then it can leave divots and crevices inside, microscopic divots and crevices inside of your system, which can end up with your parts failing more preemptively than they should. So there's a couple ways we can avoid air contamination inside your system, and so that's with system air bleeds, which are generally designed in from point A. Make sure that we have proper reservoir design, and also using return line diffusers. That's kind of the best ways that we see to negate air inside of your system. So the goal in a hydraulic system is to have laminar flow. And what laminar flow is basically if you were to draw lines of flow direction inside your system, they're all parallel to each other. When we start getting turbulent flow, the lines are no longer parallel and they start crossing each other, and they create little vortexes and places for turbulence to develop inside the system. And this can create either cavitation or also just entrain air into the system. If we look to the right over there, having a proper diffuser inside of your reservoir is very important. That way it can help with laminar flow in your system reservoir, which prevents that air buildup and foaming. And then on top of that, it also just allows for your particulate to settle out to the bottom. It keeps particulate out of the fluid in your reservoir from being entrained in the system. So a lot of people will talk about the filtration efficiency of an element, and this is how we like to talk about what the cleanliness rating an element will give you into your system and how that works. So a lot of people will talk about beta ratios, and what a beta ratio is basically a different way to discuss the efficiency of the filter. So if we look at this filter that we have right here, we have 100,000 particles upstream of the filter, and then we'll count the number of particles that are on the downstream side of the filter, and that will give you your beta ratio. So if we have 100,000 particles on the upside, your fluid goes through your filter and you come out with 50,000 particles on the downside, you have a beta ratio of 2. And then a beta ratio then refers to efficiency, which basically then turns out to 50% efficient. The magic number that you will see talked about all the time in beta ratios is beta 200. And beta 200 means that you are 99.5% efficient of filtering out a certain size of particle. So when we're talking about beta ratios, we'll say a beta ratio of 200 at a micron size. So we're talking 10, 5, 2, possibly 20. It all depends on what our end goal is with the filtration efficiency of our system. So for example, if we're talking about 5 microns, we're going to say, I want a beta ratio of 200 on 5 micron. That means for every 100,000 particles upstream of the filter, we will then have 500 particles downstream or less, resulting in a beta 200 or 99.5% efficiency. If we're looking over here, you can see the other kind of just kind of the correlation between beta ratio as well as capture efficiency. So 200 is 99.5, 1000 is 99.9, 100 is 99.0. So it's just a good idea to have a reference of what people are talking about when they say beta ratios. Here's just kind of a nice idea to get a perspective of what a relative particle size is. So for example, 100 micron is a grain of salt on a table, pretty much. So 0.0039 inches, and you can see that with your eye. Now we start getting a lot smaller here, and what we were talking about before on micron ratings was we're talking like 20 micron down to 2 micron. And with that, like you're talking about 2 micron, that's the size of bacteria. Absolutely minuscule. And if you look at the relative size under 500 times magnification here, not going to be completely to scale due to computer screen sizes, but we really do have that, like the differential between a 10 micron particle and a 2 micron particle is quite significant. And then if you look at, for example, the 40 micron, it is a lot larger than your 10 micron. And we just got to really bring that down to, we're talking about milk, flour, red blood cells, bacteria, all down that size where we'd never ever be able to see them with our human eye. And a lot of people will sit there and go, well, my hydraulic fluid is clean because I can't see anything in it. The things that we're talking about here with the filtration of hydraulic fluid is filtering things that are not visible to the human eye. If you can look at your hydraulic fluid and you can see that it is dirty to the eye, you had filthy, dirty hydraulic fluid. We really want to make sure that gets cleaned up. So hydraulic oil cleanliness requirements. The way that we talk about hydraulic oil cleanliness is through what we call ISO codes. And the ISO code is talking about 3 different particulate sizes and how many particles you can have in each one of those buckets. So the ISO code, if we look here on the top right, we have 19, 16, 13. So that first number, 19, refers to the number of particles greater than 4 microns. The 16 refers to the number of particles greater than 6 microns. And the number 13 refers to the number of particles greater than 14 microns. So when we're talking about these, the number of that ISO code then refers to a bucket of particulate ranges. So if we look at 19 here, ISO chart 19 right here means that you have more than 2,500 particles and less than 5,000 particles. So if we look at this here, you see 19 particles. It's of 4+ microns of the actual particulate count of the range per milliliter of 2,500 to 5,000. Same thing goes for 16 with the 6+ micron, and then 13 for the 14+ micron. And with ISO code, you'll generally see them in decreasing order because the smaller the particles are, the easier they, or the harder they are, excuse me, to filter out of your system. And as a result, it's going to be you're going to have more particulates. So if you're counting 4+ microns, that counts all of the particles that are going to be in the 6+ micron bucket and the 14+ micron bucket. So it's kind of a cascading cumulative result right there. So the thing is, each one of your system components is going to have a design for hydraulic cleanliness level. And with that, that'll be specified by your manufacturer, whether it be a servo motor, a servo actuator, or a piston, you name it, there will be a desired ISO cleanliness code. And as you can see here, basically the smaller the clearances you have, the cleaner you're going to want your oil to be. So for an anti-friction bearing, your component clearances are basically 0.5 micron. Vane pump, you're talking 0.5 to 1, gear pump 0.5 to 5 micron, servo valve 1 to 4, and then you kind of get farther up here where you have a lot larger clearances. And that's going to result in the cleanliness of your oil being higher for those parts that have smaller clearances. So servo control valve, 17, 14, 11. If we go back to this page right here, 17 refers to 4 micron here. So we're going to have more than 6,400 or 640, but less than 1,300 parts per milliliter inside that 4 micron bucket. Realistically, we have kind of a guideline here of what the ISO cleanliness we're aiming for is, but it's not the hard and steady fast of what you need. But realistically, you want to go look at what your OEM on your components is talking about, and then we can go and design for system cleanliness from there. This next chart right here is a little bit of an eyesore. It's hard to read, but as Joe mentioned, there is that hydraulic cleanliness handbook that he has linked in the control panel there on the right, and you can actually click onto that. Click on it, and then we'll go from there, and you can go into that handbook and kind of get a better look at this more closely, because we're just going to very briefly glance over it. So basically, for example here, this is a hydraulic system chart to give you an idea of what type of filtration you need to get to a cleanliness code of 17.14.2 for a servo valve at a system pressure less than 1,000 psi. So basically, beta efficiency, beta ratio of X, so these are talking micron ratings, beta efficiency X greater than 200 at either 2 micron or 5 micron, number of filter placements 1, and that'd be minimum filter placements, so 1 pressure filter. Or here we have using 5 micron media, 2 filter placements at pressure and return. And then you can kind of go through here and get those ideas. But realistically, these are suggested cleanliness codes that are kind of common throughout the industry, but you really want to look at your OEM suggested and what's suggested by the manufacturer of that cleanliness level there, and then use that to specify your system overall. So now we're going to kind of talk about like what is the approach that Parker uses. And what we use is the total system health management kind of philosophy. And with that, we have a diagnostic bucket of products, we have a therapeutic bucket of products, and then we have a preventative bucket of products. So the way that Parker looks at hydraulic fluid cleanliness is that you want to make sure you know what's happening in your system, you want to treat what's happening in your system, and then you want to prevent having particulate and other issues inside your system in the long term. So we start off with a diagnostic bucket of tools here, and these really start off with our particle counters. We have a wide variety of different particle counters. The first two here are going to be particle counters that are mounted into your system, and they will give you information on the current cleanliness of your fluid as it is actively running inside the system. The next options that we have are portable particle counters. This one right here can sample off of like reservoirs, so you go in a reservoir sample a new unit that might be going out in the field, or you just fire it up to see the cleanliness of that oil. And then these two products right here, the LCM20 and LCM30, are portable particle counters that you can plumb into test ports on your system and then see the particle counts of that system, and then take the particle counter and move it to a different location on the same system or on a completely separate one. And then finally, we have a offline kind of lab-based bottle sampler, where you can get this, bring this into your lab, and then have all of your particle counts made in your lab. And then you can print out basically a birth certificate or information right there on what you are seeing for your ISO code and particle counts. We also have oil condition sensors that are meant to be mounted in line. The first one's the metallic wear debris sensor. This is used a lot on expensive bearings, where if you're going to have any metal particulate in your oil, it could absolutely foul up and be a huge expense to replace that bearing, as well as a lot of downtime. And then we also have a fluid property sensor as well as a fluid condition sensor, which measure different characteristics of the fluid, and then based on that, you can maintain your maintenance schedule. The next we have is the therapeutic bucket. So as I mentioned before, when you have clean fluid, you really want to make sure you clean that fluid before moving it, or you have, I should say, bulk fluid. You want to clean that bulk fluid before you move it into your system. And we have a couple different options for doing that. The Parker Guardian series right there is just a nice little handheld pump that will move bulk oil from a drum into a system. Nice little handheld unit there. The most common one that people use a lot for larger applications is going to be the filter cart there. 10 gallons per minute. It's on wheels. It's got 2 ModuFlow filters on there, as well as you can also actually get it with the particle counter on there. So if you wanted to go to a reservoir that you have, you know that the cleanliness is lower than its ideal, you could use that cart, go plug it into your system, turn it on, and then clean that fluid until you have the desired ISO cleanliness that you want. Next, we have our offline filtration systems here. The ones that we're primarily going to talk about are these two right here, which is our Parker Sentinel and our Parker PVS. These are vacuum dehydration units, and what they will do is remove both particulate, air, and water from your system. So if you're having issues with water inside your fluid, you'll want to look at either talking about a Parker Sentinel unit for smaller applications, or for larger applications, Parker PVS unit. And we have a lot of use for these in high humidity applications, whether it be paper mills, hydroelectric generation, pretty much anything with regards to trying a high humidity environment. The SMR unit, most people won't have a run-in with those. Those are primarily used in stamping applications in automotive plants. And then the Crossflow here is kind of a cool multi-featured unit, which is primarily used on mobile applications. It includes a return filter here. It's got a cooler for the oil, sight gauge, breather, and then it also acts as a reservoir. So you can have a smaller hydraulic reservoir on your mobile application rather than just having a reservoir that you have to make larger because your fluid is getting hot. The next spot that we have in here, and then finally we move into our preventative category of products. And this is what most people think of when they think of hydraulic filtration, because this is indeed our filters. We have our filters broken out into quite a few different product categories, but they can basically be grouped into low pressure, medium pressure, high pressure, and then breather type applications. So the first we start off with is our low pressure applications. The Parker AT series is a spin-on cam line, good for up to 150 PSI. And then we move into the Parker PT and GLF, which are both tank top mounted return filters. And the cool thing about these is they can work very well inside your reservoir, and that reduces your footprint size. But then also they're designed so that the fluid flows through the outside of this element here, and then is laminar flow into the fluid and results in a lower amount of air in your system, and it can work to prevent foaming and air entrapment. Finally, we have the Parker ModuFlow, which is low pressure inline option. It's very common in large applications due to the fact you can flow up to 125 gallons per minute, but it does have that duplex option, so you can have 2 filters on one housing with a switch there to switch between, so you can have constant online filtration and not have to shut your system down and change your filters. Next thing that we have is our medium pressure line. These are good up to about 350, 400 PSI for our smaller stuff. And then we go up to 800 to 1200 on some of the larger things, including MPD. Parker Pure Force series spin-on cans. These are a nice addition to our line that we were able to add when we picked up Baldwin from the Clarcor acquisition with Parker. Parker CS series, 400 PSI, up to 50 gallons per minute. Parker IL8, this is a very, very large filter used a lot in very heavy, large industrial applications. Paper mills, once again, power generation, you name it, where there's a lot of fluid being used. CN series, we get a little bit higher into 800 PSI, and then the Parker NPD is a 150 gallon per minute, 1200 PSI inline duplex option. for larger applications as well. Finally, on the hydraulic oil filtration side, we run into the high pressure filtration, working our way from kind of smaller to larger here, niche applications here with the stainless steel line, and then MPDH, duplex option for a high pressure 3,150 gallons per minute. Basically, if you have a high pressure application, generally we're going to try to fit you into what's best for you. I talk with your Kundinger rep or myself about what you're trying to do and what the best application is. That's really what we're here for. We have all these products at our disposal, and we have the knowledge and the background to be able to implement these products into application that fit them and size them properly for exactly what you're trying to do. So we'll take a look at your system, what your desired cleanliness is, and put together a combination of maybe low, medium, high pressure filtration options that will best serve your system in the long term and allow us to increase that life. Finally, we move into desiccant breathers. These are what we're talking about to put onto your reservoirs to prevent ingress of particulate as well as moisture into your breather. We have a wide variety of these that are for different sizing applications. We have mobile versions that are more robust with the idea of them being put onto a mobile truck that might see more vibrations. But once again, talk with us. We'll figure out what your application is and figure out which one of these options is best for you to extend the life of your oil and prevent moisture from getting in there. So key takeaways here are, with one of the largest filter portfolios, the Parker Filtration Group has the products and the expertise to provide world-class filtration solutions. So just as I mentioned on the slide before this, we really want to work with you as a partner through Kundinger to get you the proper filtration for your system. And the way we're going to do that is we're going to diagnose what your issues are. We're going to figure out if we need to implement any therapeutic solutions to fix the issues you currently have. And then we'll implement a preventative approach to where we will figure out how to prevent the issues that you're having from happening again. And it all comes down to partnering together and figuring out what the ultimate goal is for your system and how we're going to achieve that through the most efficient, the most robust, and the most the solution for you and your team that will work the best for the life of your product. And the way we do that is by leading with filtration. Once again, leveraging the assets, the health management strategy, using our 3 pillars, bundle solutions. So don't just think about just filtration. Think about starting with clean fluid through a therapeutic option. Start with thinking about what are we actually seeing in our system and looking at it by diagnosing using a particulate counter or by bottle sampling or looking at what the actual cleanliness in your system is. Embrace and apply new innovative products. Use the technical benefits that are in our new products that are patent protected to increase the life of your system and also allow your system to work properly. Attend product and technology trainings. The fact that you guys are here today talking or listening to me talk about hydraulic filtration is already a step in that direction, and continue to do that with the Kundinger Presents series. And it can really improve the competency that you have, as well as allow you to be knowledgeable about what you're trying to do. And then once again, deploy and align with the TMs with your field personnel. So talk with Kundinger, talk with myself, and we can work together to really come up with a great solution for what you are trying to ultimately accomplish there and how that's going to work for you. So with that, I kind of wrapped up a little bit early. It's currently 9:45, but I really wanted to thank you guys for your time and appreciate you hopping on here. And I'd like to open up the floor for any questions that anyone might have at this time.
Phil, there is one that was typed in on the chat, bringing up the clean vent. So I know a lot of people here maybe aren't even familiar with the clean vent. I don't know your experience with it, but they asked if it helps reduce or eliminate both particulate and water. So can you give us a little synopsis on the clean vent? I can pull up a PDF if you'd like,
yeah, could you pull it up? So the clean vent is actually not out of our group, believe it or not. It comes out of another group inside of Parker. But it's basically a reservoir isolator, and it does protect against the ingest of basically airborne contaminant. So we're talking dust and also water vapor. So there is both of those things that the clean vent will help prevent. I'm not as well versed on it because we don't technically sell it out of my division. But if you wanted more information on that, I can get you hooked up with the proper individuals that really do know a lot more about it than I. But it does prevent both particulate as well as moisture ingress.
Yeah, I mean, it's basically it kind of would replace your desiccant breather, right? I mean, it's gonna.
Yep. It's a bigger version. We've primarily started moving towards desiccant breathers for applications where it allows. More often than not, you don't need the full clean vent. The desiccant breather will do what you need it to.
Okay.
If we size them properly and have them on the proper replacement schedules.
Okay. All right. I don't see any more questions. I'll pull everybody off of mute. If anybody's got any questions before we end this, you're unmuted now. You can ask that question. All right. Well,
where can you find that chart that shows, the cleanliness levels for the different types of equipment? I looked through that HTM-4 thing. I didn't notice it in there.
In the material that I added, it's not in there?
It was, in the program, it showed, different types of components and what the level is you want. But I went through that HTM-4 PDF, and as I scrolled through it, I didn't really see that. So where can you get that from?
It should be in that in the handbook there. Let me double check though, because we did just alter the handbook. So that's the European version there. We did just alter the handbook. I will also put a PDF version of this PowerPoint that we had and send that to Joe to distribute to the people who attended today. So you can grab it off of either the slides there, but it should be in that hydraulic filtration handbook.
Yeah, I see it. It's on page 5.
Let's see.
Or if you go deeper into the manual, page 21 or PDF page 23, lists the component types and the different ISO suggested cleanliness levels.
So can you see my screen here?
Yeah.
Yeah, so here's the filter media selection. Here's this. This is page 19 of the hydraulic.
Hold on, Phil. I have to give you. I had stolen the presenter.
Oh, got it. Here we go. So, Joe, were you able to put this, the hydraulic handbook hydraulic filtration onto the contents?
Mine might be a little different because the link that you sent was a little difficult to get loaded, so it might be a little different. But it does have some.
Yeah, we did try to resend this one out because I know it's a little larger of a file, but this is the most up-to-date one that we have. So the front page looks like this. It's the handbook of hydraulic filtration, and basically it'll go through all of these, like basically what we talked about more in depth though. So it talks about contamination and size. It talks about your types of contaminants. It talks about your particulate ingress, water, talks about air, and it talks about fluid cleanliness standards. So it kind of gives you a better rundown of the ISO charts that we're talking about. And then we talk about how media works and all those different things with surface filtration, depth filtration, different types of media. And then we'll talk about beta ratios again. And then we get into like our filter media selection and what we're doing here. And this is the chart. Was that the chart you were talking about?
Yeah, I believe so, because the one that was linked has a 10/05 date on the catalog, or what? Yeah, it says the catalog HTM-4.
Yeah, we'll try to get that changed out to be this one because this is a more up-to-date up-to-date handbook that we've been using. It's kind of hard. I'll try to get it linked either via a SharePoint link or on the Parker website. I know that we're still working on. This will ultimately be a published, like you'll be able to go to Kundinger, and Kundinger will have these actually printed that Parker will provide. So.
Yeah, because we have some of our customers want us to test our test oil, and the cleanliness level they're looking at is more stringent than what we generally have. And we're trying to find, maybe where they got their information from, or,
Yeah.
Larry, I can have get this sent to you.
okay.
That shouldn't be a problem. We'll get a link to that, and we'll get. I believe you're probably dealing with Ryan Stortecki, right?
Yeah, I believe so.
Yeah. So I'll make sure either he or somebody gets this link sent to you, so you got the most up to date one.
Yeah.
Anything else? Any other questions? All right. Well, thanks for participating today in our Cunninger Presents, and thanks to Phil for the great information on how to keep our hydraulic oil clean. We've already talked about the materials section and how we have that in there, and we'll get some updates here to some of this stuff. So if you want to, any more questions, want to talk to anybody, please reach out to your Cunninger contact or email us at sales@cunninger.com. Or you can call our 1-800-242-4811 number. And then a last pitch here is to just follow us on our LinkedIn to stay up to date with all of these webinars that we're doing and product information, service information that we share on our LinkedIn page. You just got to search Cunninger on LinkedIn and you'll find it there. So with that, thanks, Phil, and thanks to all our attendees for taking time out of their day and joining us. That's all I've got.
Once again, thank you guys. Appreciate the time and look forward to working with you.
Thank you.